Principles of Bioproduct Separation, Module 4, Cell Disruption, Segment 4. With me again, Yusuf from Institute Teknologi Bandung. Previously, we have discussed about cell membrane, chemical methods, and mechanical methods. In this segment, we will focus on exercises related to cell disruption. We will discuss two questions. Question 1. Use the Van Hoff's relationship to estimate the osmotic pressure across the membrane of a cell undergoing rupture in a 0.01 molar salt solution, assuming the internal salt concentration is 0.2 molar and that all salts are fully dissociated at 20 degrees C. Would you call this negligible, ordinary, or large pressure drop? Why? Question 2. It is customary to prepare hemoglobin by the osmotic lysis of red blood cells. What is the Van Hoff's pressure drop across the membrane of a red blood cell that is isotonic, with a total solid molarity is 0.3 molar on the inside and submerged in a 0.01% sodium chloride solution at 20 degrees C? What is the expected outcome of this situation and why? Solution for question 1. According to the Van Hoff's law, osmotic pressure equals to the R times T multiplied with the concentration difference inside and outside the cell. Since the salt concentration are given as molar and they are fully dissociated, it can be assumed that they are binary salts. The total solid molarities are 0.4 molar and 0.02 molar outside the cells, and at 20 degrees C, the osmotic pressure equals to 9.14 atm. This is a relatively large pressure drop from the inside to the outside of the cell. The cell membrane would break due to water flowing in unless there was a cell wall surrounding the cell. Solution for question 2. External sodium chloride concentration can be easily calculated and determined as 0.00171 molar. Assuming that sodium chloride dissociates into two ions, the total solid molarity outside the cell is 0.00342 molar. According to the Van Hoff law, the osmotic pressure can be determined as 7.13 atm. For such osmotic pressure, the expected outcome is that the red blood cell will rupture, since the cells do not have a cell wall to protect the cell membrane from rupture. Now is the time for pop quiz. Try to write down your answer when listening to the questions and discuss with your friends. First, what is the chemical method that are gentle but expensive? Second, how to scale up chemical methods of cell disruption. Third, what is the major problem in mechanical method of cell disruption? Fourth, what is the antithesis of enzyme digestion? Fifth, how much volume of pure water is necessary for the osmotic shock treatment? What happens if the pressure outside the cell is larger than the inside? How much volume of detergent is necessary for detergent solubilization method? What does amphipathic nature means? How much volume of toluene is necessary for lipid dissolution method? What is the good way to choose proper solvent for lipid dissolution? What are the 3 small-scale mechanical methods to disrupt cells? What are the 4 important variables in a homogenizer? How to correlate measured time constant with other variables? What are 2-dimensionless groups that can be used to describe diffusion? Last but not least, what is the physical meaning of Grashof number? You may want to check these videos in YouTube for a better visualization about cell disruption. In the next module, we will discuss about extraction. Until then, I am Yusuf from Institute Teknologi Bandung.